All right, so having a look at this triangle question, I've pulled my three triangles out and drawn them all separately. So I've got triangle DEF, DSR, and SEQ. We're told that the area of each of them, sorry, that should just be an A, not an A1. So we've got area A, area A1, and area A2. And we can also tell from those diagrams that these three angles here are equal and these three angles here are equal, which means that all three of those triangles are going to be similar through the AAA test. So in part one, you would have already proved that these two were similar. And in part two, you've already proved that dr over df is equal to x over x plus y. And that's because these two are similar, so you can compare the ratios, and the ratios have to be the same. You can do that as well in this triangle, which we're going to have to do in part four, but we'll get to that in a little while. So for part three, it asks us to prove that the square root of a1 over a just simplifies down to be this. So what we're going to do is we're going to go through and find the area of this triangle and then the area of this triangle and prove that it simplifies down to this. So if we're looking at the area of this, I just realised I forgot to put the letters on there. If we're looking at the area of this triangle, we can use the sine rule. And because they've all got these angles the same and we know stuff about this side and this side because of here, we're going to use this angle in the sine rule. So our sine rule is half AB sine C. So in this triangle, this is going to be our A and our B, and our sine C, our angle C, is going to be this one here. So our area is going to be a half times dr times ds times sine of D, the angle here. And then if you find the area of this triangle, we're going to have a half times df times de times sine D. Now looking at that, the sine D and the sine D can cancel and the half can cancel. So we're going to be left with dr over df times ds over de. Now we know from part two that dr over df is just this. So we can have x over x plus y. And we know that ds over de, well, ds is x and de is x plus y, so we can have x over x plus y. So that's the same thing as having the square root of x over x plus y squared, and then the square root and the squared will just cancel out to give us x over x plus y. So that's part three. Part four asks us to do something similar to parts 2 and 3 and end up proving that the square root of a is equal to the square root of a1 plus the square root of a2. So what we're going to do first is we're going to prove, like we did up here, we proved that these two were similar. We're now going to prove that this one's similar to this one, and that's just because they're equiangular. So I'm not going to write that whole thing out, but triangle DEF is similar to triangle SEQ by the AAA test. And then because those are similar, then we can compare sides. So we can say that SQ over DF has to be equal to SE over DE. So if we write that down, we're going to have SQ over DF is equal to SE over DE. And from that, SE over DE will be equal to y over x plus y. So very similar to what we had before, except a y instead of an x. Now we can find a similar expression. Up here we found an expression for a1 over a, square root of. This time we're going to find the square root of a2 over a. So if we go the square root of a2 over a, that's going to give us the square root of, if we go through and find the area again, we're going to have a half times SQ times SE times sine D over a half times DF times DE times sine D. And again, we can simplify things down. I'm not going to go through this whole thing step by step, but we're going to end up with SQ over DF times SE over DE. And that will simplify once we plug things in. So we know that SQ over DF is this, and we know that SE over DE is that as well. So we'll end up with y over x plus y squared, which is just going to give us y over x plus y. So now that we know this guy up here, is equal to a square root of a1 over a, and we know that a square root of a2 over a is equal to this. The tricky part here is being able to see that if you were to add these two things together, they have the same denominator. So when you add them together, you're going to get x plus y on the top, which is the same as the denominator. So if you add them together, you end up getting 1. So I'm going to squish the rest of the working over here. So if I do the square root of a1 over a plus the square root of a2 over a, that's going to give me x over x plus y over x plus y, which would give me x plus y over x plus y, which gives me 1. So that means that this thing added together is 1. Now I'm going to rewrite these. When you take the square root of a fraction, you can square root the top and the bottom separately. So I'm going to write it as the square root of a1 over the square root of a plus the square root of a2 over the square root of a equals 1. Now because they have the same denominator, we could write that as the square root of a1 plus the square root of a2 all over the square root of a is equal to 1. And then we can multiply both sides by the square root of a. So we're going to end up with square root of a1 plus the square root of a2 is equal to the square root of a, which is what we're aiming for if you flip it all around. All right, so that is parts 3 and 4 of question B.